let's look at solving some logarithmic equations. So in these equations, we're going to be using three properties of logs to rewrite and solve these equations. The first is the property of equality, and it says that two logs with the same base are equal if and only if the numbers or expressions inside those logs are also equal. That's the property of equality. So log base b of x is equal to log base b of y if and only if x equals y. And that means that goes the other way, if and only if. So it means if x equals y, then those two logs are equal as well. The product property of logs says that two logs with the same base, when you add them together, they equal a log with the same base of the product of their values. So here we have log b of x plus log b of y, that equals log b of x times y. So if we're adding the logs together, we just multiply their values. And the quotient property says that kind of the opposite. If you are subtracting two logs, then that would equal a log with the quotient of their values. So if we're subtracting them, then we divide their value. So here log base b of x minus log base b of y equals log base b of x divided by y. So let's practice simplifying some logarithmic expressions. We'll write them as a single log, and we'll use the properties above. So here, example 1a, we're going to use the product property. And so we'll end up multiplying these two values together, and we get log base x of 20. 10 times 2 is 20. For example b, we're going to multiply, because we're adding, multiply this expression times 3. So we'll get log base x, and then we have to distribute that 3. So we get 21a plus 12. And example C, again, with the addition, we're using the product property. We're multiplying their values. So log base x of 18a. Notice all these logs have the same base. They must have the same base for this property to work. Now let's look at some quotient properties here. We have log base x of 30 minus log base x of 3. And this would equal log base x of 10. 30 divided by 3 is 10. For example E, we'll have log base x 12a divided by 2a is 6. 12a divided by 2a, the a's cancel. 12 divided by 2 is 6. And example F, log base x, and then to divide these, remember, divide the coefficients and subtract the exponents. But it could be helpful to write this out just in case they don't subtract easily, like this. So first of all, 25 divided by 5 is 5. Now we have a to the 6th and a to the 9th, but 9 is on the bottom. It's bigger, so we're going to have an a to the 3rd on the bottom here. And then 7 minus 4 for b. So you could put this in parentheses if you want, or just make it clear, but I think I'll put some around it. So there we go. That's how to simplify some expressions using the product and quotient properties. And now let's get into solving some equations using the property of equality as well. So here we have log base 5 of 4x equals log base 5 of 40. Since these are equal, we know that their values are equal. So I can write an equation 4x equals 40, and so x equals 10. Notice we didn't even use the base of that log at all. All we need to do is confirm that those bases are the same. For example B, we have log base 4 of 6x plus 4 equals log base 4 of 2x plus 28. So again, we can set these equal to each other. 6x plus 4 equals 2x plus 28. Well, we can subtract 2x from both sides. We get 4x plus 4 equals 28. Subtract the 4, we get 4x equals 24. And finally, x equals 6. Same idea here. Just confirm we have base 2 for both. So 2x plus 7 equals 21. Subtract 7 and 2x equals 14. So x equals 7. Now let's look at how to maybe combine some properties here. We have log base 2 of 4 plus log base 2 of x plus 1 equals log base 2 of 16. So first of all, I'll combine these two using the product property. That will give me log base 2 of 4x plus 4. And that is still equal to log base 2 of 16. Well, I know that these two expressions are equal, so 4x plus 4 equals 16. So 4x equals 12 and x equals 3. Similar idea for example E, except we are using the quotient property, so I'll do 20 divided by 5. So log base 3 of 4 equals log base 3 of 2x plus 4. Well, just set these equal to each other. 4 equals 2x plus 4. I think that should have had some parentheses around it in that problem. But that plus 4 is supposed to be part of that log. Anyway, we'll subtract 4. We get 0 equals 2x. So x equals 0. All right, so there are 3 properties and how to use them to solve logarithmic equations and simplify some logarithmic expressions.